Hi everyone, and welcome back to By Ramya. Today we're going to be going over Unit 5. Luckily for you guys, last unit was not my best. This unit is super easy for me, which means it's going to be 100 times easier for you guys. So let's just get started. First, 5.1, Tragedy of the Commons. What is the tragedy of the commons? Well, it's a tendency of a shared resource to be depleted because of self-interest. I want you to imagine what happens at the dinner table. Let's say you have a bunch of brownie bites in front of you and your family's crowded around the dinner table. Well, your brother takes half of the brownie bites for himself. And at that point, it's everyone just grabbing as many brownie bites as they can because they know it's going to run out soon. Because your brother took a huge share and now everyone else is like, oh, I need to get my share, it's unfair, whatnot. The same thing happens with the tragedy of the commons, except it's with things like, for example, our oceans. So the US or some countries like, oh, I'm going to take a bunch of resources, and other countries are like, wait, if you're going to do that, we might as well do that as well, right? Because we all share the resource and this will benefit us. If you're doing it, it's unfair that I can't do it either. And so all the countries band together to help themselves in their economy, but then it hurts the environment. And so that is the tragedy of the commons, when there's a shared resource, but it's depleted because of self-interest, because your brother was like, I'm going to take half of these brownie bites for myself. The next vocab word for 5.1 is externalities. Externalities is the cost or benefit not included in the purchase price. What does that mean? So let's say I bought a bunch of paper. I bought this paper. An externality would be maybe I have a risk of getting paper cuts. It's not included in the actual monetary cost, but it is a side effect. It's a consequence. Externalities can be both positive or negative. But then there's negative externalities, and that is the next vocab word. And that essentially means the cost suffered by a third party because of economic transactions. So this means a negative consequence that was unintended that you weren't necessarily buying. Let me give you some examples of negative externalities: noise pollution, air pollution, traffic, overfishing, dead zones. Essentially, whenever you're fishing and you fish too much, you don't necessarily think of the environment. You're thinking, oh, the transaction that's happening is I'm catching fish, selling them. But what's the unintended consequence not in the price? Well, you might be overfishing. It might cause environmental problems in the lake or ocean. That would be a negative externalities. Oftentimes, the third party that is hurt by us is the environment. Hence AP Environmental Science. So what are some solutions to this? Well, it's hard, but the main solutions that we have in place are, for example, taxes. So you fine someone for overfishing, potentially, regulations, property rights. So for example, if someone has to claim, I'll claim this part of the sea, well, then they're responsible for taking care of it. And the tragedy of the commons won't happen anymore because they will be responsible for it. The problem with the tragedy of the commons is that no one person is like, I can claim that you guys cannot take all the brownie bits. Just everyone, every country is out for themselves, trying to help themselves. There's no real regulator. The next vocab word for this 5.1 is max sustainable yield. And this is actually a pretty easy concept. So the max sustainable yield is the max amount of the resource that can be taken without depleting it. So for example, let's say that there are 4 churros, and if I take 2 away, another 2 will reappear in 2 months. So if I take 2 churros away and I leave them for 2 months, well, then 4 happen and it refills. Well, that's the max sustainable yield. If I took another churro, if I took 3 churros away, it would only refill to 3 churros instead of 4. So when does max sustainable yield happen? It's actually a super easy concept. Whenever the population is at half carrying capacity, that's when we consider the population to be at max sustainable yield. So let's look at this graph right here. K is carrying capacity. And so halfway here, or right in the middle, right there, that is where we would consider the max sustainable yield to be. Super easy concept. If you have a graph question, well, you just got the answer there. All right. Next, we're going to talk a little bit about water. So, water, what do you have to know about water? Well, there's a small percent of the ocean or of the water in our world that is fresh water. And groundwater is what we call aquifers. And aquifers are often overdrafted. And really just think about you take too much so that it can't replenish itself. Same thing with the churro example. I've taken too much water out. Now that water can never replenish itself to what it was before. So aquifers are often overdrafted. That sometimes leads us wondering, is there going to be a freshwater storage shortage? Because we won't necessarily have enough fresh water moving forward if aquifers continue to be overdrafted. People take too much water, use too much water, and that water can no longer be replenished or refilled. It's not sustainable anymore. What's going to happen? Our fresh water is going to disappear, and it's only a small percentage of the water in our earth. And so that's problematic for us, because then if the fresh water runs out, we can't drink ocean water. All right, now let's move on to 5.2, clear cutting. This one's going to be super short. What is clear cutting? Clear cutting is cutting or removing every tree in an area. Let's say this is a forest. These are all the trees. I remove every single tree. It's all gone. Now, I want you to think about this. What are the impacts? Well, in the short term, it's actually beneficial for some people because they cut every tree in an area, they get timber, they make money, but that's very short term, and it only helps one country's economy, or maybe one person gets some cash. But in the long term, it's really, really, really bad because global warming. What happens when you cut down all the trees and then there's more carbon dioxide that isn't taken in by the trees and oxygen isn't spit out by them? We have less oxygen, we have more carbon dioxide, global warming, climate change gets worse, and overall really bad because it can have extinction level impacts. But let's try not to think about that. Another problem is that natural habitats are destroyed whenever you clear cut a forest. So there used to be a gopher, a monkey in that forest, and you cut down all the trees, they're gone. They have to find somewhere else. And again, if they can't find a niche in time, they're dead. That leads to species extinctions and a loss of biodiversity. So clear cutting has lots of impacts. The majority are negative for the environment, but there is a short-term economic boost. So 5.3 is all about the green revolution. And a lot of the concepts in here we're going to be talking about in actually later concept areas. So I'm just going to skim through this. A couple of things you need to know here is that the green revolution essentially just made it easier for us to have high yield crops. We used to have small farmers who used to, in small batches make yield crops. But at the time there weren't, and like we couldn't feed everyone. But we started introducing these things called GMOs, new fertilizers, pesticides. GMOs specifically are genetically modified organisms. And with that and new fertilizers and pesticides and advances in irrigation, we were able to see a higher crop yield, which means more crops were produced. And so we're actually able to provide for a lot of people. And so these GMOs, genetically modified organisms, are genetically modified so that they are higher yield, that they are pest resistant. However, all of these great things also have side effects. We don't actually know the full the full side effects that GMOs can sometimes have. We know that sometimes it might not be beneficial to our own health to ingest something from a genetically modified organism. And for new fertilizers and pesticides, sometimes they may kill good insects, which hurts other wildlife. Sometimes some of the insects that would be there would actually be beneficial to the ecosystem. And so by helping ourselves, we're still destroying our ecosystem. Not very fun. All right, now we're going to move on to 5.4. 5.4 impacts of agricultural practices. This one is going to be a little heftier than some of the others. Bear with me, some of these vocab words are super simple and you will understand them, I promise. If you have any questions, feel free to use the comments below. All right, let's just run through these vocab words that you need to understand for 5.4. The first is undernutrition. What is undernutrition? It sounds exactly like it is. Not consuming enough calories to be healthy. Your calorie count is under what it should be. What does malnourished mean? Malnourished means your diet lacks protein and vitamins that keep you healthy. So you need to eat more, most likely, and you need to have more proteins and vitamins. What is famine? Well, famine is deaths per day per 10,000 people due to lack of food. Yeah. What is overnutrition? Overnutrition means having too many calories. We don't see this happen much in less developed countries, but for example, in the US, we do see rising, for example, obesity rates, and that could be a result of overnutrition, too many calories. The next vocab word is actually really relevant today: food deserts. That's when high levels of poverty occur and there's limited access to a car. Nearest grocery store is a mile or more away. So what does this actually look like? Well, let's say I'm in the middle of nowhere in rural America and I don't have access to cars. I'm in the lower income bracket. And if I want to get to a grocery store, the nearest grocery store is a mile or more away. And so I can't really go to the grocery store and be super healthy because it's going to be really expensive for me to get there and it wastes a lot of my time. And it's very, very hard to get there. So what happens instead? We see that people who are experiencing food deserts, they just go buy fast food because guess what? It's fast and it's cheap, but it's not good for you. And so because of that, we're seeing not so great health levels in a lot of Americans and in other countries. The next vocab word is pretty easy. Conventional agriculture. What is conventional agriculture? With conventional agriculture, we use factories, we use machines, and this is directly opposed by traditional farming. And so that is used in more of the developing world and that where human labor is the primary method. So in conventional agriculture, that's what you see in the US predominantly, where it's machines doing the majority of the heavy lifting. But in traditional farming that we see in many developing countries and developing worlds, we see humans taking the brunt of this work because machinery isn't as readily available. And so just think of it as traditional farming, tradition, the old way, conventional machinery. Think about it that way. What is monocropping? Well, it's essentially large plantings of single species. What that means is if you just fill an entire field with corn, that's monocropping. The entire field, you just grow corn, monocrop, only one crop. That's what it means. The next is sustainable agriculture. What is sustainable agriculture? It fulfills needs for food while enhancing quality of soil and minimizing non-renewable resources. What does that mean? So first, it sustains the need for food. It gets you the food because that's what we need to eat. But it helps the soil. It enhances the quality of the soil. It tries to keep the nutrients preserved and it minimizes the non-renewable resources, which basically means we're not going to deplete resources. We're going to try to keep the resources so that we can sustain and we can keep using these resources for a long period of time. So sustainable agriculture, great. They're doing great things. Let's look at some examples of sustainable agriculture. One thing that is used is intercropping. So monocropping is actually not used for sustainable agriculture, but what intercropping is kind of the opposite of monocropping. It's where two or more crops are planted on the same field, and there is some interaction between them. So think of it as monocropping. Mono means one crop, and then intercropping, between two or more crops. Inter means between. So think of it that way. And intercropping helps replenish the nutrients in the soil typically, and it's just more efficient in general. And so that is why we like it. And stay with me here, only a couple more terms that you need to know left. What is contour plowing? Contour plowing is a plowing and harvesting parallel to the topographic contours of the land and prevents erosion by water. What does that mean? Basically, if you have a bunch of lines that make contours in the soil, so indents in the soil, you try to prevent erosion by water, because if water is on top of this mound that you've created, like there's one contour here, and there's some soil, if water flows here, the water is only going to drain the soil right back here into the contour, so the soil remains trapped. This is like agroforestry that prevents erosion, and less erosion leads to a lower likelihood of deforestation, or in desertification, where it kind of like the entire field becomes deserted. There's low vegetation and you can't support much plant life anymore. So erosion, bad, and contour plowing prevents that. This might be on FRQ, so definitely this is something you might want to keep in mind. All right, next term, no-till agriculture. So no-till agriculture is letting the leaves and roots stay in after to maintain nutrition and prevent erosion. So basically, sometimes tilling means that you take out the leaves and the roots of a plant entirely, but no-till agriculture means you're not taking out the leaves, you're not taking out the roots of a crop. You're going to maintain nutrition that way. You're going to keep nutrients in the soil and prevent erosion, which we talked about is pretty important. GMOs, genetically modified organisms. We're going to be talking about the benefits and the drawbacks or concerns. Benefits of GMOs: high yield. We can actually aim to potentially reduce world hunger, or at some point eliminate it entirely because of things like GMOs. That's a very real thing. We have a better quality of crops. They just taste better. They're more nutritious. There's less of a pesticide use because some of these genetically modified organisms themselves are made to be resistant to pesticide, to insects. So farmers don't need to use pesticides. Reduce world hunger this way. And we also increase food profits, because if there's more corn or more products to sell, farmers and countries are going to make more selling the food. And so they have higher profits. What are some concerns? It's our own personal safety for humans. If we eat these genetically modified foods, it could be harmful for us and sometimes poisonous or a little toxic. There might be effects on biodiversity. So for example, if we're mass producing only this one type of GMO, there's going to be a loss of biodiversity because we're controlling, we need this specific type of plant and that's the only thing we're growing. All right. With that, we're going to move on to 5.5, irrigation. And we're going to talk about irrigation methods from the most evaporation, aka least efficient methods, to the least evaporation and most efficient methods of irrigation, of essentially watering your crops. That's what irrigation means. All right, so let's go down the list. Furrow, flood, spray, drip. I want you to memorize that order. That's most evaporation, least efficient to most efficient. Just think about it this way: least efficient, most efficient. So furrow, flood, spray, drip. Now let's go over what they actually mean. So furrow irrigation is when you dig trenches. So there's a lot of soil, you dig a big hole, probably like a straight line, and then you fill those trenches with water. This is about 65% efficient. Next, flood irrigation. This is more disruptive than the furrow method. The furrow method, you're just digging trenches, but for flood, you're going to literally flood that entire field with water. And it is 70 to 80% efficient. So it's more efficient, but more disruptive. So there is a trade-off there. Next is spray. So spray is exactly like it sounds. Think of your sprinkler. The water sprays. And it does cost more money than furrow or flood. That being said, it is 75 to 95% efficient. So it is very efficient. Lastly, we have the most efficient, and that is drip. So basically, we'd have like a dripping hose underground, and it would be dripping water to the crops. This is over 95% efficient. The problem, and it's actually good because there's less weed growth because the surface is completely dry. The drip is happening underground. The surface is dry, and so you're going to have less weed growth. Let me give you a couple warnings in terms of just the impacts of bad farming and our human impact on land. So one thing I want to talk about is over harvesting. That is one impact that can go really wrong with harvesting. Over harvesting essentially just means harvesting too much. There's a bunch of corn and you took too much of it. You harvested the entire crop of the entire field of corn, and now the soil is left completely drained and there's no nutrients left for anyone else. So that hurts the environment. The next thing is tillage. Sometimes when we do tillage, we take away the roots and leaves of a plant, we completely till it. Then we loosen the topsoil. I think you can probably guess where this is going. If you loosen the topsoil, it's susceptible to erosion, right? Like if you dig up a plant, then the soil is going to loosen. It can be blown away by the wind, and that top layer is going to be eroded over time. Wind can carry it away, and that's problematic because it can lead to desertification, which we're about to talk about. Desertification is when fertile land becomes desert-like. For example, in China, the Gobi Desert, I believe, expanded by I don't remember the exact statistic, but 35 miles or something like that because of desertification. We're actually creating deserts in places that were previously hospitable because the land is no longer fertile. We're not taking care of it. Erosion happens and it becomes desert-like, and there's no biodiversity there.